Good afternoon, ladies and gentlemen. Thanks to ICSAE committee for inviting me to present my research. First of all, I want to introduce myself. My name is Hidayatul Faiza and I'm undergraduate program of Agrotechnology of 11 Maret University. Let me introduce our research team and supervisor. Mr. Supriyono, Mr. Bambang Puji Asmanto, and Mrs. Maria Teresia Sribudiastuti. Today, I want to present my research. Replacement of potassium chloride with organic fertilizer on cultivation of Porang, Amorphophallus Muelleri Blume under Sonokeling stands. Porang, Amorphophallus Muelleri Blume is a tuber-producing plant that grows well under the Sonokeling stand. The glucomannan compound in the tuber of Porang are commonly used as raw materials in the pharmacy, food, and cosmetic industry. This makes the demand for porang export in the form of chips to various countries such as Japan, China, Korea, Australia, Sri Lanka, Italy, and Malaysia to be high, reaching 10,000 tons per year. Intensification of porang cultivation activities need to be done to meet export need, one of which is through fertilization. Fertilization activities in porang cultivation generally use inorganic fertilizer such as potassium chloride. Potassium element content in potassium chloride has an important role in the process of formation and translocation of carbohydrates. However, the continuous use of potassium chloride has the potential to decrease soil fertility, including causing the soil to become hard, reduce the soil's ability to store water, and converting soil pH into acid. Based on this, the use of potassium chloride needs to be replaced with organic fertilizer. One type of organic fertilizer that can be used as a substitute for potassium chloride is cow manure. This study aims to obtain the influence and replacement of potassium chloride with organic fertilizer that causes the highest porang yield. The research was held during March until July 2020 in the forest area of PKPH Pojok, Kemado Batur, Tawang Harjo, Grobogan. Tools and materials needed include rules, meters, thermohygrometers, lux meters, scale, knife, potassium chloride, organic fertilizer, marker, name tag, and porang pens. This research used a randomized complete block design one factor, and the treatment was the replacement of potassium chloride with organic fertilizer with percentage. This treatment consists of 6 levels, which each level repeat 4 times. Data from the observation are processed with analysis of variant level of 5% and DMRT level of 5%. Result of the research divided to 3 parts. First, general condition. Second, observation of porang growth. And third, observation of porang yield. General condition. Research location is area with little soil types. Little soil has a physical, chemical, and biological properties that are not good enough for plant growth because it is a relatively young type of soil with a raw texture. This is accordance with the result of the initial soil analysis of the research location that saw the content of nutrient is low until medium with slightly acidic pH. Climate condition at the research location is suitable from the growth of porang. Rainfall on the last 10 years has an average of 180 mm per month, which is included in the middle category. Average of temperature ranges from 25.3 degree until 29.9 degrees Celsius. This temperature is suitable from the growth of porang, which is near the temperature about 22 degree until 30 degrees Celsius. Average of relative humidity ranges from 67 until 88%, and average of light intensity at range from 35.68 until 45.48%. This research used a potassium chloride Kujang brand with potassium oxide content of 60%. Organic fertilizer used in this research is a manure cow that has compost with brand of Rojokoyo and content of potassium about 1.33%. Observation of porang growth. There is no obtained growth plant data in this research include plant height, stem circumference, and leaf length after the replacement of potassium chloride with organic fertilizer. This is because most porang plant has fall, which is characterized by drying of the leaf and stems. Porang has fall because of the excessively high temperature at the research location, especially the average temperature on March, which reached 34.8 degrees Celsius. This temperature causes the leaf of plant has burned. Porang has fall also because the plant has entered the dormant phase. Porang plant in their life cycle will enter the dormant phase during the dry season. This condition is characterized by the fall of plant vegetation. Observation of porang yield. The observation parameter of porang yield include the tuber fresh weight, tuber storage weight, tuber diameter, tuber thickness, and tuber chip weight. Tuber fresh weight. Based on the diagram, it is known that partial replacement of potassium chloride with organic fertilizer is able to increase the tuber fresh weight. This is evidenced by the tuber fresh weight on the treatment of 75% potassium chloride with 25% organic fertilizer and 50% potassium chloride with 50% organic fertilizer are higher than the tuber fresh weight on the treatment of 100% potassium chloride. This show that the potassium chloride partial replacement with organic fertilizer is able to increase the efficiency of nutrient absorption, especially potassium for fertilizer by plants. The application of organic fertilizer cannot replace the overall use of inorganic fertilizer, but can increase the efficiency of nutrient absorption from inorganic fertilizer. Tuber storage weight. The diagram shows that the replacement of 100% potassium chloride with organic fertilizer has not been able to produce the highest tuber storage weight, but the partial replacement of potassium chloride with organic fertilizer is able to increase the tuber storage weight than the use of 100% potassium chloride. On the treatment of 75% potassium chloride with 25% organic fertilizer and 50% potassium chloride with 50% organic fertilizer produce a high tuber storage weight because organic fertilizer that act as a partial replacement dose of potassium chloride is able to improve the soil fertility. The increase in soil fertility is caused by the content of organic matter, macro and micronutrient contained in the organic fertilizer. Tuber diameter. Based on the diagram, it is known that partial replacement of potassium chloride with organic fertilizer is able to increase the tuber diameter. This is evidenced by the tuber diameter on the treatment of 75% potassium chloride with 25% organic fertilizer and 50% potassium chloride with 50% organic fertilizer are higher than the tuber diameter on the treatment of 100% potassium chloride. The height of tuber diameter on the treatment 75% potassium chloride with 25% organic fertilizer and 50% potassium chloride with 50% organic fertilizer was due to this replacement dose being able to meet the needs of growing space conditions optimally for tuber enlargement. Enlargement of tuber is closely related to the activity of deficient and enlargement of cell. These activities can run optimally if there is enough space for cell division and enlargement. Tuber thickness. From diagram show the replacement dose of 75% potassium chloride with 25% organic fertilizer and 50% potassium chloride with 50% organic fertilizer is able to increase the tuber thickness as evidenced by the tuber thickness in this treatment is higher than the treatment of 100% of potassium chloride. This treatment can produce the height of tuber thickness because added dose is able to improve the physical properties of the soil that can support the process of formation and enlargement of tuber optimally. The structure and aggregate of soil turn into loss to the addition of organic matter in the into the soil. Tuber chip weight. Based on the diagram, it is known that partial replacement of potassium chloride with organic fertilizer is able to increase the tuber chip weight. This is evidenced by the tuber chip weight on the treatment of 75% potassium chloride with 25% organic fertilizer and 50% potassium chloride with 50% organic fertilizer are higher than the tuber chip weight on the treatment of 100% potassium chloride. The increase of tuber chip weight on the treatment because there is potassium element that can meet the needs of porang plants. Application of organic fertilizer as a potassium chloride partial replacement is able to increase the efficiency of nutrient absorption, especially potassium. Based on the result and discussion, can be concluded that potassium chloride give a strong effect on the yield of porang, which includes the tuber fresh weight, tuber storage weight, as well as tuber chip weight, and organic fertilizer is able to replace the role of potassium chloride. The use of potassium chloride and organic fertilizer was selected based on the yield of highest tuber diameter and thickness and appeared with the same percentage. It is 50% potassium chloride with 50% of organic fertilizer. This all is our result research, and on this opportunity, the author would like thanks to Mr. Wahyu Kunchoro as a President Director of Perum Perhutani and his rank for the research permit granted to us. LPPM UNS team for funding according to the non-APBN research agreement and Grobogan District Agricultural Department for the good cooperation. That's all my presentation. I apologize for any mistake on word. Thanks for the opportunity that given to me, and also thanks to a great attention for the audience. I return to the committee and thank you so much.